Welcome to the ActiveStor 18 Overview webinar. I'm John Murphy, Marketing Manager at Panasas. We are very excited about the launch of ActiveStor 18 and are happy you have joined us for our product overview. During the course of the webinar, we ask that you enter any questions you may have in the questions section of the control panel of your screen. We'll address questions at the end of the presentation. With that, I'd like to introduce to you the presenter for today's webinar, Geoffrey Noer, Vice President of Product Management at Panasas.
Thank you, John, and it's a pleasure for me to be here once again for a brand new product launch, ActiveStor 18, Hybrid Scale-Out NAS. I know there are some of you here that are new to Panasas and others that are existing customers and partners, so I'll be presenting a blend of information in today's webinar, so hopefully all of you get out what you are attending here to get. So just to start with the introduction to Panasas itself, we were founded in 1999 to bring into being a cutting-edge, next-generation scale-out NAS technology that is ideal for industry and research applications. So the target markets are everything from manufacturing, life sciences, energy, even weather, media and entertainment as a relatively new focus for Panasas. So all of these are spaces that have a major focus on large unstructured data sets requiring high performance, ease of management, and high reliability. Panasas has a global presence with more than 500 customers in over 50 countries. So wherever you are, chances are there's a Panasas system nearby. And as our customer growth has continued to escalate, we've been investing more in terms of the organization here at Panasas, and I wanted to highlight a few recent executive management ads that we've made, starting with Tom Shea as our Chief Operating Officer, Jim Donovan, Chief Marketing Officer, and then in the European, Middle East, Africa region, Martin Eves, our new VP of Sales for EMEA, and then more focused on the industry verticals and our channels are David Salek, VP of Industry Marketing, and Phil Crocker, Director of Channels. So this all speaks to an increasing commitment at Panasas to grow the business. If you're curious about where Panasas came from, a lot of this actually goes back to the groundbreaking research that Dr. Garth Gibson has been behind, starting with his being one of the original 3 co-authors of the Berkeley RAID paper that defined all of the RAID levels that you're used to with in the storage industry. But he also went on to be one of the primary people behind object storage in the 1990s at Carnegie Mellon University, and that led to the creation of actually 3 different parallel file system technologies based on object storage that are pretty well known in the industry today. Panasas he founded as the commercial vehicle to his research. However, the Google file system and the open source Lustre file systems also share a similar heritage. The difference being that as a complete appliance solution of hardware and software, Panasas was focused on enterprise-grade reliability and availability and manageability from the start, whereas some of those other technologies were primarily more focused on performance as being the main goal for the technology. So performance is certainly no slouch with Panasas. We've been able to deliver extremely high performance, but it's never been at the expense of those other areas. We are privately held with venture capital coming from premier firms such as Moore Davidow, Focus Ventures, and Centennial Ventures. We also have technology investors including Samsung Ventures and Intel Capital. So what is high-performance hybrid scale-out NAS all about? Really what it comes down to is the combining of performance, management, and reliability all in a single product. When we look at the competitive landscape, we see products that were engineered for performance that are typically standalone file systems. This might include both Lustre and GPFS, but were not engineered for ease of management or for reliability. You also have products that were created for the enterprise that deliver a lot of the manageability and reliability, but don't have the true scale out back end and true scale out front end, and so from a performance standpoint comes short when it comes to delivering time to results for a lot of these high performance workflows. So on the performance side, true scale out architecture means that you have linear scaling. Every additional drive, every additional blade that you add to our architecture adds not only more disk, but also more CPU performance and more networking. So the whole thing scales as you scale the storage. And to that point, we now have customers in the last year who have actually scaled up to 13 racks of our storage in a single global namespace. And that increase in scale, combined with the larger hard drive sizes supported in ActiveStor 18, allow us to make a very conservative claim of being able to scale to more than 20 petabytes and 200 gigabytes per second. Architecturally, we're capable of much more than that. And if any of you on the line are interested in a larger system, I'm sure our sales force would be very interested to talk to you about that. There's no inherent limitation. It's just that we like to make our marketing claims around what customers have actually done in the field. And in our case, that's more than 20 petabytes and 200 gigabytes per second. The other aspect of performance is that this is a flash accelerated hybrid architecture, meaning combining disk and flash. The challenges of a drive-only solution is that small file performance tends to be underrepresented in the solution, and you end up with a system that is only good at benchmarks for large file streaming performance and doesn't do as well in the real world. And then on the opposite side, you can have a 100% flash solution that delivers amazing performance but is so expensive as to never be, to not be practical for a large-scale unstructured data solution. Manageability, being able to install in under 10 minutes, and then as you scale, being able to scale really trivially is really a cornerstone of the product. So I'll speak more about that. And then from a reliability standpoint, not using hardware RAID, but using erasure codes in software, which changes the characteristics of the product from what you might be used to seeing. Most storage products get less reliable the bigger they get, and it's an all-on or all-off proposition in terms of availability. We have triple parity protection. We've really changed the name of the game, where reliability increases with scale instead of getting worse, as you would normally expect. And we've changed the availability model for the product, where you're talking about what percentage of the file system is accessible. That will almost always be 100%, but if it can't be 100%, it's better that you can access almost all of your files than none of your files, which is what you would see with other solutions. So I'll walk through all of these in a little bit more detail. First, let me talk a little bit about the platform itself. So the ActiveStor platform is an appliance consisting of hardware and software. There are two types of blades that deliver different types of storage resources to the system. One is the director blade and the other is the storage blade. Director blades are responsible for metadata access, and they orchestrate the access protocols for the system. Storage blades, on the other hand, perform direct I/O with the Panasas Direct Flow protocol, which is the premier choice for high performance from Linux clients. So in a direct flow model, the directors sit out of band. They only tell the Linux compute clients where they should then go to store different pieces of the file. And then all of the reads and writes occur in parallel without any further use of the directors. And so this is the secret behind how we can scale the performance linearly at very high rates. It's always a single global namespace, a single system to manage, and the total cost of ownership, because of not having to, for example, pre-buy storage ahead of time, you can pay as you grow. The fact that you don't need a forklift upgrade because you've run out of performance. You can simply just add more shelves and grow the performance as you need. All of those, and then the ease of use and manageability of just being able to have one system administrator regardless of how big the system scales. Those are all elements that have tremendous value when it comes to understanding the total operational cost of the system. What about ActiveStor 18? So this is a great new generation for Panasas. It's of course bigger and faster, like you might expect for a new platform release. 33% increase in density based on a choice of either 4 or 8 terabyte hard drive configurations. The linear scalability now goes up to 20 petabytes or 200 gigabytes per second, as I mentioned earlier. And we've also taken the opportunity to double the amount of storage blade cache and increase the speed of the director CPUs, which further accelerates small file and metadata performance. The increase in density comes about through the use of HGST HE8 helium-filled 8 terabyte hard drives. We're not a single vendor storage solution by any means, but we're leveraging the HGST drives for the product introduction with their lower power footprint and the high capacity that they deliver, and the good experience that we've had with their 6 terabyte technology based on similar approach. We feel very good about the quality and the performance of this particular drive choice. We also have flash, of course, because this is a hybrid system, and we size the amount of flash specifically for our RAID 6 Plus data protection, as well as for the typical small file count that most high-performance workflows would expect to see. And I'll talk a little bit more about that in detail in a couple more slides. A couple of additional notes on the storage blades. One is that actually the 8 terabyte drives are our first 4 kilobyte native sector drives that we're supporting. This is a little bit down in the weeds, but it's interesting because advanced format, as the hard drive industry refers to it, is a way of getting about 10% improved areal density out of the drives, which is part of how you get to 8 terabyte drives. And it also just allows for a larger transaction to the underlying drive mechanism. So we've made changes to the PANFS file system that allow us to leverage these drives, and that support is available as part of ActiveStor 18 release. We've also doubled the amount of cache. With 1.6, this should say it's 8 gigabytes per blade, or 160 gigabytes per shelf. And at a rack level, 1.6 terabytes. And so the bigger the system grows, the more cache that you have in the system. And this allows you to cache a much larger portion of your active data set than you might normally expect to see, because RAM cache is usually a fairly limited commodity in a traditional storage architecture. So this is why we actually don't need to use flash for cache. We have plenty of cache in the way of RAM memory, and the bigger the system, the more RAM there is. And so, and we've doubled it relative to ActiveStor 16. So between that and the faster director blade CPU, which is 19% faster, the two of those together give you a real-world advantage of about 20% in terms of accelerating metadata and small file performance relative to prior generations of Panasas product. On this slide, you can see a picture of a storage blade with 2 8 terabyte hard drives at the bottom, 16 gigabytes of cache memory, a lightweight CPU, and a 480 gig SSD. So this illustrates the proposition that you scale the resources, not only the amount of disk, but you scale the amount of networking and CPU at the same time as you scale. And this is why the linear performance scaling happens in addition to the linear capacity scaling. You add all of the right resources in the right proportion as you grow the system. A typical shelf has 11 of these blades, so it would typically have 10 storage blades and 1 director blade. From an overall architectural perspective, we're very agnostic when it comes to the type of client and the type of networking that's used to access the system. We have customers that have mixes of Unix, Linux, and Windows workstations, and for that matter, large Linux clusters, of course, accessing a single storage system from Panasas. And sometimes that's over 10 gigabit, sometimes that's over InfiniBand, sometimes it's over a combination of both of those. So we really make it possible for a heterogeneous environment to experience all the advantages of a high-performance storage solution. Our premier protocol is a protocol called DirectFlow, which is actually very similar to the open standard PNFS, which is still in the process of rolling out. Panasas was one of the companies behind the PNFS initiative. But DirectFlow is actually a fully commercially hardened version of PNFS that we've been shipping for 10 years. And we would encourage you to check it out as really a primary way of not only having a scale-out storage backend, but also a full scale-out front-end protocol. And it's by combining front-end and back-end scale-out solutions that you really get a full, true scale-out experience. In addition to DirectFlow, we also support NFS and SMB, and those two protocols are also scalable through the addition of additional director blades. These protocols are implemented really in where resides all of our secret sauce, which is the parallel file system itself, PanFS. So that's our storage operating system. It runs on the ActiveStor hardware platform, which is then delivered as a complete appliance to customers. I think it's useful to talk a little bit more about hybrid. So certainly flash storage has become one of the most talked about areas in the storage industry right now. It's a big change from what hard drives have been able to accomplish for many, many years now. Rather than having a rotating media with a head that has to move around, flash is of course solid state based, and that allows the random I/O to be much superior to a hard drive, which has to seek the head back and forth to get to the right part of the platter. So what this means for real-world performance especially is that it's relatively easy to make a large file aggregate benchmark that's basically all streaming large files and get very high performance off of hard drives. And that's what a lot of the benchmarks like IOR and IOZone can measure very easily. The problem is that most real-world environments consist of tens or maybe even 100 different applications accessing storage simultaneously, with a range of different file sizes ranging from the very small to the very large, all hitting the data storage at once. And that's what we refer to as a mixed workload environment. The problem here is that those small file accesses will interrupt the large files from being able to be streamed off of the hard drives if it were an all hard drive environment. So the question becomes, well, a combination of flash and disk would appear to be the best solution for this scenario. But how much flash and how much disk, and how to put those technologies together in a way that's very easy to use. So we started out before we even launched ActiveStor 14, which was our first mass market product that included disk and flash. We went to our customer base and we looked at these high performance workflows to understand what do the data sets actually look like? And what we learned is that 60 to 80% of the files by count are smaller than 64 kilobytes. So lots and lots of tiny files, even though the performance and the focus of a lot of our customers tends to be more on the large files. So then the question becomes, well, how much capacity do those files use? Well, 60 to 80% of the files sounds like it might consume a lot of data storage space. But what we found repeatedly is they take up about 1% of the capacity. So combine that with the metadata capacity that you need to store the metadata for all files, and that takes us to our approach with the hybrid technology that's part of ActiveStor. So we've taken a tiered approach where flash and disk are both used for persistent storage, not for cache. So the cache again is the memory in the system, the RAM memory. And you have a big pool of that, 1.6 terabytes per rack worth of storage. So we don't need to use the flash for cache. Instead, what we do is we automatically tier data within the file system based on the nature of the data. If it's a small file or if it's metadata, we automatically store it on flash. If it's large file content, we store it on disk. That allows us to provide best-in-class mixed workload performance because the small files come off of very high IOP flash devices, and the streaming performance can go uninterrupted from the large capacity hard drives. And from a price performance standpoint, as you can imagine, only having to have a few percentage points of your capacity from flash makes the solution very affordable, because you don't need to have, flash is still about 10 times more expensive than disk from a dollar per terabyte standpoint. But most people can afford to spend 10 times as much on 1% of their storage. So that's the rationale behind our hybrid leadership. The important thing to point out is that from an end user or an administrative perspective, you really don't need to know about the fact that there are two tiers. It just looks like one big directory space, and you store your data normally, and you don't need to worry about it. We'll just automatically take care of the placement of the data so that you can take advantage of flash versus disk. Linear scalability is very easy to claim, but it's the proof is in the pudding, and being able to actually demonstrate that linear scalability is very important. We have that proven out at Rutherford Appleton Laboratory, currently our largest deployment in the world, with more than 20 petabytes of Panasas storage installed over 3 generations of product. If you actually ask the administrators at RAL what they consider to be the strongest suit in the product, they'll certainly acknowledge the high performance of the solution, but the first thing that actually comes to their mind is how easy it is to manage, and the fact that they can have one part-time storage administrator managing more than 20 petabytes of storage. That's almost unheard of, and it has a tremendous impact on the cost of operations of the system. Well, for their second generation of ActiveStor product, when they installed it, we actually had access to the cluster for a short period of time to be able to do benchmarking. And while the number of compute nodes that we were given access to were insufficient to drive the full performance of the Panasas system, we were able to show perfect linear scalability of reads and writes going from 10 to 20 to 40 to 80 to 90 shelves. And we would only see maybe an additional 10% of performance if we were able to have doubled the number of accessing nodes. So we came very close to proving the maximum performance with Panasas, and we're very confident that if we just had a few more clients, we would have actually shown the exact marketing numbers that we've always been able to prove at a slightly smaller scale. The last major area of differentiation, I've already talked about 2 of the major areas. So the direct flow protocol and the ease of use and manageability, I think, are really 2 of the biggest highlights for Panasas. The third is the reliability at scale and how we handle data protection, because it really is very different from the way that other storage solutions approach reliability and availability. So the old school way of delivering reliability is with hardware RAID. And of course, since our founder was one of the original people to come up with the concept of RAID, we're going to be the last ones to say that was a failure, or that the mathematical approach to delivering that type of reliability, of course, that's been very successful for the industry, and it's made a huge difference. It's been a cornerstone of the way that data storage has protected data over the years. However, if you look at the way that the original Berkeley RAID paper laid out data protection, it actually didn't specify that RAID had to be performed at a hardware level, even though that's the way that the industry has generally delivered it over the years. RAID is actually the application of a mathematical construct called erasure codes that can be deployed and delivered in a number of different ways. And ultimately, the best way with very high capacity drives is to use them in software rather than in hardware. The problem with hardware RAID is that you're protecting entire hard drives at a block level without really understanding the file level implications. We protect data on a per file basis instead. And we have triple parity protection, so we can survive 2 entire hard drive or device level failures, but we can also independently correct any of the individual sector errors that come up on a per hard drive basis. The whole reason for RAID 6 being invented was to be able to handle the case of one hard drive failing and then during a RAID 5 rebuild running into an additional bad sector somewhere. Well, the problem is there's so many sectors now on these 8 terabyte hard drives in a RAID set that there's a fairly good probability that you're going to run into multiple sector errors. And in that case, a traditional hardware RAID can't handle that scenario. With our triple parity protection, on the other hand, we don't even need to start a rebuild if we run into a bad sector. We can repair it in line. So we can not only detect these sector errors, but we can actually also correct them because of the third level of parity. We also do a lot to limit the rebuild effort, because rebuilding 8 terabytes of data, if you only need to rebuild a few kilobytes, is a total waste of time, and it actually makes you more exposed to additional failures. So part of the benefits with Panasas is that we detect what kind of failure it is, and then we do the minimum amount of work necessary to be able to restore full data protection. So if it's a clump of sectors that went bad, we probably only have to rebuild a few files, not a whole hard drive. If a whole hard drive goes offline, we leverage all the other drives in the system to do the rebuild so that the rebuild speed scales linearly with the size of the system. We don't just contain that rebuild within, for example, a 10-drive hardware RAID set. So that allows our rebuild speed to scale linearly with the size of the system. And then finally, and this is maybe the hardest concept to explain over a webinar, is that we randomize the distribution of the data with erasure coding. And this allows us to actually increase the reliability at scale, because with the more drives that you have in the system, the less likely any given file is to share those 3 drives as if you were to incur a triple failure. So what that means is the predicted rate of damage to files from a triple failure declines from 1 in 200,000 files with 100 drives in the system to 1 in 200 million files if you have 1,000 drives. So it's a huge improvement in reliability just by leveraging the scale. And because you have a faster rebuild rate as you add more components, those two aspects are offset from each other. So the basic level of reliability stays constant instead of getting worse. And then the randomized placement actually allows us to lower the effect of having those too many failures simultaneously. So it's important when you have all of your eggs in one basket, as you do with a scale-out solution, to really have designed the reliability and availability models for that sort of a scenario. So the probability is very, very low, but if you do get very unlucky, what situation do you want to be in? Do you want to be in the position of maybe having to restore 5 petabytes of data from backup tape? Or do you want to be in the position of having a list of 5 files that were affected and be able to just restore those 5 files to get your system back to full health? And that's what's possible with Panasas. Our customers clearly believe this story. So we've now had RAID 6 Plus out in the field for nearly a year, and we recently asked our customer base, and this was a statistically significant sample size, how important is RAID 6 Plus to you? And 78% of the respondents stated that RAID 6 Plus was either important or critical to their operation. And the others were probably, quite frankly, using it in a scratch space configuration where the data was easily regenerated. So the majority of our customers really do care about the data protection and the reliability over time, and that's of course of increasing interest as data sets are kept around for later use and reuse. And we see that in all of the markets that we serve. The last major topic that I wanted to talk about was the ease of use and manageability. So under 10 minutes to set up and deploy really makes the whole operation, it removes all the headaches. When we've talked to our reseller partners, the amount of cost for every day that's lost on the acceptance up front, where clusters are idled because of a storage system that isn't up and running yet, there are in many cases millions of dollars that have been spent on the overall cluster, and every day that cluster sits idle is a lot of value that's been lost. So being able to set up in less than 10 minutes removes one of the biggest headaches from high-performance computing deployments. We also make it very easy to recognize new storage. When you plug in a new shelf and you log into the administrative console, it will say, "Oh, I see you've added a new shelf. Do you want me to add this to the existing file system?" And if you say yes, presto, it's done. And then in the background, the system will automatically redistribute the data so that the data is evenly balanced across the whole system. And that avoids hotspotting that might be present with other architectures. And of course, we keep the system easy to manage. So Serviceability is very straightforward. If a blade fails, you replace the blade. The system automatically rebuilds and rebalances. You never have to run any additional special commands to try to understand what's going on. It's just a very simple: pull out the bad part, put in the new part. The system does the rest. If you want to be able to limit how much capacity users can use, we have all the enterprise features around snapshots, user group quotas, those types of functionality. We also have SNMP management, even XML interfaces that you can use to pull data out of the system. So it's a very flexible and a very rich set of management tools and features. So with that, I'd like to bring the webinar to a close. ActiveStor 18 obviously takes the ball forward in a number of different arenas. Certainly the performance is improved. We continue to do great things with data protection and scalability. So the 100, going from 150 gigabytes per second to 200 gigabytes per second, more than 20 petabytes worth of scalability proven in the field. Data protection that increases with scale because of RAID 6 Plus. The performance improvements with the faster director blades and the doubled cache. All of this is part of the Panasas advantage of delivering storage that scales as big as your ideas. We really don't believe that cluster storage or parallel file systems need to be your number one headache. It should really be about how do you extract value out of your data sets and how do you create more business differentiation for whatever the purpose that you're buying the storage for. It shouldn't be actually managing the storage. So we want you to focus on your value add and do all of the heavy lifting when it comes to delivering a storage solution that is not only very fast but very easy to use and manage, and that is highly reliable and available. So with that, I'd like to thank you very much for attending today's webinar, and I would like to go ahead. I can see that we've already got some questions in the queue. If you haven't already posed them, please go ahead and type them into the question box, and we'll get to them as we can. John, what questions do you have for me at this time?
Okay, Jeff, we have a few in. First up is, what is the maximum file size? Or file system size, sorry.
So actually, those are actually both good questions. So the file system size and the maximum file size are actually both unlimited architecturally. It's really a question of how big the physical system that you've deployed is. So there are certainly storage systems out there that have a cap on how big an individual file can grow. In our case, it's the size of the system. So you can create a file system that's pretty much as big as you want it to be. If you have a 20 petabyte file system, for example, on the high end, if you wanted to create a single file that was 20 petabytes in size, you actually could do that. We have a lot of customers in the field in the energy space, in government, and some other markets that create multiple or even tens of terabyte sized files. So we have customers that routinely work with very large files and also with very large numbers of files too.
Great. And next up we have, what version of Mac OS do you support?
Yeah, so sort of the first really high level question, if I can abstract that a little bit, is sort of how important is heterogeneous IT support, and is that a common scenario? And that is one of the big differences between some of the open source or software only file systems, that those are very Linux focused specifically. And it's true that our direct flow protocol is an equivalent path to getting extreme performance out of large Linux clusters, and it is usually Linux where we see the biggest demand for the aggregate, the very high loads of aggregate performance. But at the same time, the way that we support NFS and SMB for Windows is also very important and very capable on the Panasas system. We have multi-protocol locking, which I see as another question that came in, is sort of how do you handle these legacy protocols? And the system basically will round robin all of the NFS or SMB clients across the director blades, and so you can have a fully scalable levels of performance with those legacy protocols as well as the direct flow Linux protocol. Mac OS is an operating system that we're increasingly seeing in the media and entertainment space, especially for post-production. And I'm happy to say that Mac OS is a fully supported environment for NFS with Panasas, and we've had very good experience delivering high levels of performance with macOS with NFS. In fact, Apple has done a good enough job with their NFS support that in some cases we see slightly superior performance with macOS than we do with Linux on NFS. So they're both very strong, but macOS is definitely an environment that we're increasingly seeing, especially in that market.
Okay, great. Here we have one. What is the hardware look like per blade? 2 times 2 gigabit, or is the hardware load balancer install in front?
Okay, so let's go back to the architectural image that we had a while back in the presentation, showing the shelf of blades. So one of the ways that we scale the product is by scaling the number of network uplinks from the shelves as you add more of them. So each shelf has a pair of 10 gigabit Ethernet ports for 20 gigabit worth of bandwidth. And if you think about the performance that 20 hard drives can deliver, it's a little under 20 gigabits worth of performance. So you're scaling the number of drives and the amount of networking along with the CPU necessary to drive that performance as you're adding more and more blades into the system. So that's one of the big strengths of the architecture. Now, in terms of load balancing, with DirectFlow in Linux, there is no load balancing. Every client can talk to all of the storage blades simultaneously. So it's really an N to M matrix, right? All of the clients can talk to all of the nodes simultaneously, and so you don't run into some of the problems with hot clients that you can experience with NFS or SMB in other environments. Now we do support those legacy protocols like NFS and SMB as well, and in that case we do a DNS-based round robin to load balance the accessing NFS and SMB clients across our directors. So you simply put together a hardware configuration that is a little bit richer on director resource than you would on a DirectFlow configuration, and then you have enough directors to deliver the full performance of the system over NFS or SMB. So basically built-in load balancing, very easy to use.
Great. Well, that concludes the questions we have. If you have a question, please submit it to info@panasas.com, and also for those that are viewing this as an on-demand webinar. And again, we'd like to thank you all for attending today, and we look forward to interacting with you in the future. Thank you.